All right. So let me just quickly go over this, right? We want to use the pair plot. It shows scatter plot for all numerical combination in a data set along with histogram. So pair plot is a combination of scatter plot and what? An histogram, right? Now, plotting one of the Seaborn inbuilt data set called Iris. Iris is a data set in Seaborn, inbuilt data set in Seaborn that's used for classification tags, where we have 150 sample of iris flowers with 4 features: sepal length, sepal width, petal length, and petal width, and a target variable, which is our y, which is the Sentosa, to want to predict if the flower is Sentosa fascicolor or virginica. So that is basically the idea of iris, but we're not doing prediction today. Yes. Now, we're going to load our data set called iris, right? So the normal way. So I'll just say iris is equal to SNS dot load underscore data set. Then I'll just pass iris. Then once I say iris dot head, get me the first 5 of my data set head. So this will just take shortly, then we'll see the result. So this shouldn't take much of time. The kernel is still loading, shouldn't take much of time. This shouldn't take much of time. All right, okay, fine. So this is it. So we have iris dot what head, right? Iris dot head. So now what are we doing now? We want to check for something, right? We want to create a pair plot for each of these. Yes. So I'm going to just say, don't forget from our material here, we said SN is the word pair plot, then we pass the whatever is holding it, then our category by what species. So my plot is going to be, the category is going to be based on what? The species. So I'll just say SNS dot pair plot, and I'll say data, data, comma, just like what we did, something similar like this, comma, then we'll say our category, right, should be what? Based on what? On species. All right. So once I run this, we're going to have a pair plot. Just it's going to take a little while to load, and we'll get it out. It shouldn't take much of time. I don't know why it's taking too much time to load. All right. So SNA.pair plot data. This is almost taking forever. Okay. So while this is still trying to load, oops, there's an error somewhere. Species. I guess my spelling, S-P-E-C-I-E-S. S-P-E-C-I-E-S. What's the error? Species. Okay. Okay. Pair plots. Pair plot. Pair plots. Data, then this is species. This is correct, right? This is correct. This is correct. Okay, let me just check again. Oh, do you know why it's wrong? I said data here instead of iris. This is supposed to be iris. Iris is what is holding this whole data set. So this is supposed to be iris, not data. So once I run this now, I'm going to have my result. It should give me my result now. It shouldn't take forever to load. It's because pair plot is not the normal other plot that is faster, right? Yes. So now, why that one is still trying to load? There are other things we can also add. There's something they call subtitle. Subtitle is just to add, when we say y is equal to 1.02. Yes. Now, if you look at this closely, right? This y is just to give it a kind of dimension, yes, of our plot. Then this one is just to add a title. Yes, that's pair plot for iris data set. So I'm going to be using my plt.subtitle. So let me see. This is still loading. Let me stop the kernel. If it's taking too much time, I will interrupt the kernel and probably I'll just load it again. Still taking time. All right. So I think it's loading. All right. So this is it, right? So you can see it. So let us just add our plt.subtitle. And I'll just say for my subtitle, I'll just say peer plot for iris dataset. Peer plots for iris dataset. Then I'll just pass my y is equal to 1.2. So once I run this, I should have the same thing, right? Then a subtitle, subtitle, and it still worked anyways. Matplotlib has no attribute subtitle, not sub. All right, so this is supposed to be P subtitle. All right, now let's proceed to the next one, heatmap. Now, what is heatmap used for? Heatmap is just basically to check for correlation. Basically, we use heatmap for when we are carrying out metrics. Yes, basically for metrics. Now, when we are carrying out, maybe we have, okay, let me say um, we are doing something like we are trying to predict our y. X is an independent variable to predict y. Y is a dependent variable. Just like, for example, let me explain this to you now. We want to check, okay, we want to check if a student will buy a laptop with certain criteria. First, is it earning a salary? Is it working? Does he have money to buy a laptop? So these are X are the parameters that can determine if this guy will buy a laptop, right? Yes. Now we can use, after we have done our predictions and all our models rather, we can now split this into different heat maps, right? So one of them will be the actual value, and the other one will be the predicted value. So the predicted value is our y, the actual value is our x. Yes. Now, and there are other calculations relating to that too. So, but once we use the heat map, we can just get whatever we want to do, right? So we want to find the correlation of all the is it the pelters, what's it called? The PS. Is it the PS or should I call it the flower parameters? Now, so we just pass a correlation. Now, basically, when you are trying to work on its map, there is something we call call. Call means correlation. Yes, correlation between this and this, X and Y and Z, P and Q, and so on and so forth. So we're going to do this, then just pass this into its map, annotate true, annotation true, CMap, that's color mapping, that's co-1, right? So just pass this whole thing and we are done. Now let's talk about, we're doing with its map, right? So I'll just say SNS dot its map. Then I'll just pass my first. I need to get correlation of all my variables. No, correlation is X and Y or the entire data set if you want. So I can just say data core is equal to iris dot core. Yes. This is a function in Python for correlation. Yes. Something like this. Yes. Okay. Now, then I can now pass I can say data core, then data core, then what again? Data core and CMap. CMap is the color mapping. I can say cool warm. Cool warm. Am I calling with this warm? Let me confirm. Yes, cool warm. And annotation, that will be what? Annotation will be what? Will be true. Annotation, that will be what? Annotate. will be what? True. So once I run this float Sentosa could not convert string to floats. Okay, what could have been the problem? But let me see what happened here. This one worked. Data.core are not true map this. Now, when you hear the word something like this, could not convert string to float, it means that I could not convert a string value to a float value, Sentosa. Now, there is a lot of things I need to do to correct this whole thing. A lot of things I would need to do to correct this whole thing. But I will not talk about those correction and all. For the purpose of this class, um I will just probably do from sepal down to petal width. I will exclude the species. Yes, I'll just do from here, since these are the same data types, from here to this. So how do I exclude species? It's very simple. I can just come here and say, I can say new iris is equal to, don't forget how to drop a column. Hope you have not forgotten. That's iris dot drop. Then I can say column is equal to species. So once I now say, first, let me get my iris first. New iris. Columns. All right. So now what I just did was that I dropped species. Yes. So I only have this. So I can now plot whatever I want to plot now. So I'm going to be using new iris. So let me just uncomment this whole thing and change this to new iris. And run it. So this will give my heat map. So you can see what we have: sepal length, sepal width, petal length, petal width, and we have all of this, right? Now, these are the different color saturations. There is a whole lot of math interpretation to this heat map. But I don't want to dive into those interpretation now because of time. So now, but just understand that heat map is just to show us the correlation between variables, correlation between the sepal length and the sepal width. Now, also take note that when we are talking about correlation, right, there are things that should come to your mind. There is something we call positive correlation. We have negative correlation. We have constant correlation. And we have no correlation. Positive correlation, negative correlation, constant correlation, and negative correlation. Now, and no correlation. When you hear the word positive, what does it mean? One is increasing, the other is what? Decreasing. Negative. What do you understand by negative? Go and make research. What do you understand by constant? Constant is none of them is increasing and decreasing. And no correlation means that you can't define if there is anyone increasing or decreasing. Now, let me say A is increasing, B is decreasing for positive. Now, for negative, we're having B increasing and A decreasing. That's the opposite. Negative is the opposite of positive correlation. Constant correlation is the both of them is following a flow. And why no correlation is none of them is, you can't say this one is having a correlation. And there are scenarios like that, right? Now, in this case of this our scatter plot, now look at this scatter plot now. Can we say the age, as age is increasing, the monthly income is increasing? Is this a positive correlation or a negative correlation? Or can we say that monthly income is increasing and age is decreasing? If it is positive, that means age is increasing, monthly income is decreasing. And if it is negative, it is monthly income increasing, age decreasing. You understand? So can we say this is a positive correlation or a negative correlation? I will leave that to you to answer that question. So let's continue back. Now, so if you look at the ones that are red, more red, you will notice that there's a correlation between this one, this one, this one, this one. Strong correlation, that's one. Then if you look at these other ones, you can see they are light, very light blue. And this one is not up to one, right? The strength of this one is not as this. Yes. So the correlation of this, or let me say the strength of this is not as strong as this one. Don't worry, there's more to this, right? In time to come, we should, in time to come, we understand what more of that, right? So now we have the violin plot. The violin, low points distribution, 1.5x interquartile. You know, when we're talking about outliers, I told you about what is called interquartile range. So violin plot is one of the plot that can help you to do that, right? So this is how a violin plot looks like. So we can want to check for attrition, right? Attrition, yes, and attrition, no, right? Now take note. Take note. Now, there is a lot of explanation to this violin plot. Now, this point here is called the median. The median. So whenever you see a point, this small dot is called the median. So we want to plot a violin plot showing attrition and monthly income. Attrition and monthly income. So I'll say SNS dot violin plot. Then I'll say data is equal to, I want to use my employee attrition data set, which is this one here. You know employee attrition data set now. We are using data, right? We're using data. All right. So I'll just come here and say data. Then I would say, don't forget, you know, we have what? The next one we have is what? If you come here, we have X and Y, right? Yes. So I'll just say for my X should be what? The let's check attrition by monthly income. So that will be attrition, then Y is by what? By monthly income. So if I run this like this now, I'm going to have a violin plot, but it's not showing different colors, right? So I'll just use a color that's pellet. Or I can use okay, I can say pellet. Pellet is equal to what? Muted. So muted will now give it distinct color. Yes, distinct color. Now look at, they said passing pellet without assigning hue is deprecated and will be removed. So in the future, they would remove this if I don't pass hue, saturation, right? So for the hue, I can just come here and say for hue, I can say hue. I can say for the hue, I can say the hue should be attrition. So if I run this now, you can see the error has gone off. All right, so we have attrition yes, attrition no. Look at the median and this. So we are progressing, right? Yes. So there are so many things we can achieve. You can use a peer plot. You can use, oh, did I say peer plot? So there is something we call subplot. Subplot is just like you want to plot two things in one place. Two things in one place. You want to plot two things, you can use subplot and pass the dimension you want, 1.1, 2, 1, whatever. You want to plot two things in one place. So I can use subplot to differentiate them. Yes, to differentiate them. Now I can just come here. I'm going to say plt dot subplot. Now look at in this place. For the first subplot, I pass my dimension. For the second subplot, we have our dimension. So for the first one, plt dot subplot, I can say 1, 2, I can say 1, 1, what? 2. That's my first subplot. I can say plt For my second subplot, PLT dot sub, is it sub? It's not sub, it's sub. No, I think it's sub. Sub, it is sub, not sub. Subplot. So this one can be one, dimension can be 2, comma 2. So now I can now pass, so for maybe I want to plot two things, right? I want to plot maybe a bar chart. Yes, a bar chart. Now let's try something now. I now say attrition is equal to data. I want to filter out data of those who have left the company. So I'll say attrition, when attrition is equal to yes, for those who have left the company. All right, yes. So that's for those who have left the company. Get me probably just the employee count. Yes. Okay, that's for those who have left the company. Then for those who are still active, I can say filter, that's what? Attrition, no. Yes. Attrition what? No. So this is supposed to be double equal to. So also employee count. Or let me use should I use employee count? Okay, let me use employee count. So now we have one, I will just copy this, or let me leave it like that. So I'll copy this and put this one up. So I'll copy this and put it up. And I also copy this and put it up. All right. So for my first subplot, I want to create a bar chart, right? I want to create a bar chart. I can just say ACT attrition dot plot is equal, attrition dot plot, I can say kind, create me what? A bar chart. Yes. Then for my second subplot, attrition, no, that's active dot plot, also creates me a bar chart too. I know instead of me using employee count, why can't I just use something like department? Yes, yes, department. So those who have left the company from each department and those who are still active in each department. So once I run this now, see what happens. Integer with 1 less than, not 2. Okay, this is supposed to be 1, 1, 2. Still having an error. 1 with 1 less than number, the number is less than or greater than 1, not 2. So I think I'm still having 2. Let me change this to 1. Let me change this to 1. So this should, why is it giving me error? No numeric data to plot. Okay, now this is supposed to plot a numeric data. Let me just this is supposed to plot the numerical data. And if you look at this closely, this one is not a numerical data unless I say dot value count. Yes, dot value count. So this becomes a numerical data. Perfect. So now, but if you look at this closely, we have just one here. But what we are trying to plot is two things. Now, how did they do it here? We have 1, 2, 1, 1, 2, 2. So let me use the same thing. 1, 2, 1, 1, 2, 2. So you can see now. So we have, this one is for those who have left the company, and this one is for those who are still working. I can change the color so it will be different. I can just come here and say color. I can say this one should be blue. I can say this one should be light blue. Then those who have left, I can say this one should be tomato color. All right. So you can see those who have left the company, that's attrition, yes. I can even add my title. I can just say, come here, add title is equal to, I can see my title should be attrition by department. Then this one is going to be title active employees by what? Department. So can you see? Attrition by department, active employee by what? Department. If you want to keep a space here, there is something we call tight layout. Yes, tight layout. You want to keep not necessarily a space, but you want to make it a little bit tight, or probably it also determines probably the space too, right? So I can just say, but I think this is even okay anyways. I can just say PLT dot tight layout, layout, OUT. Don't forget your PLT dot show. Tights. Am I wrong? Tight layout underscore. All right. So we have this, right? So there's a way to keep space. Anyways, you can find that yourself, how to keep space. So that's that. So we are cool with this. So like you are trying to build a visualization now. Like let's say you want to pass, we can still put something else here. We can still put. So let me say I want to put something else in this place. I can put, yes, I can put. Okay, let's say I want to put something like job role. Okay, let me just copy this. Let me just copy this and paste it. And this one is job role, right? And just say attrition, okay, attrition, or let me say total employee, not even attrition now, total employee by job role, total employee by job roles. So I'm going to group them by um group by total employee, then get the value count of everything. Oops, 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 oops. Okay, let me do this now. I'll just say this would be what? Data, then dot group by, then group by what? Job role. Yes. Then get me value count. There's going to be an error, I know. Group. Oh, group by job role. Is it job role or job roles? I think it's job role dot value count. Object has no attribute group. What's the problem? We have used group by before now. Okay, now, can somebody detect the error coming from this code? Can someone detect we have used group by many times, right? Yes. Can someone detect the error coming from this code? They said it's not group, GROUB, OUP, group by. We have used group by many times. So can someone detect the error coming from this code? Like, now I want to group the total employees, right, by their respective job roles, which is very simple to do. Just say group, okay, let me see, group by, okay, all right, okay, yeah. So the person that did that got it. So this is supposed to be group by. Um, and there's still an error somewhere. Product space too large to allocate array. Product space too large to allocate. I know why it's giving us that issue, right? I know why it's saying product space too large to allocate array. Okay, let me just run this. You can see it worked, right? Now, it's supposed to do something like, oh, pass, but the size of this thing is big. So for me to put another one here, I would need to reduce this size so that one can still fit in. Yes. So you can now decide to fit in another one into that space. Yes, into that space. Okay, but first and foremost, let us check if this is correct. So I'm going to come here and pass this and say job role dot value count. Why is it giving me issues? Job role, group by job roles by value count. Okay. Okay, let me pass mission. All right. So now I think this one works, right? Let me just say attrition. Wow, this is becoming much. Or let me just pass employee count. All right. So we have this, right? We have employee count. That's job role by group by job role. Then we have employee count, right? That's value count. So what if I say dot sum? So this will give me the sum of each of the job roles. So I can pass this whole thing now. Let me pass this whole thing. Let me put it here. And if I run this uh, now, then let me create another plot. Let me just copy this and paste and change this one to job arrow and run it. So can you see that there was a match, right? There was a mix. This one is the one I just did in a job role. Let me change it to job role. So you can see one is out. The space is too tight. The space is too tight. So you can see when I remove this, look at what this one did. So for me to accurately put three of them, I will need to reduce the size of this box so that it can effectively contain what I want or whatever, depends. Or what can I do? Yes, we can do something like that. Or let me copy this again. If I copy this one and I paste it here and I run this, so you can see it's not still working, right? Yes, it's not still working. Now, there is a way to correct this. Could it be the space? That could be a factor. Could it not also be the space? We'll check that. And if it is not the space, that should come down. Okay, let me see if I alter this. Can you see when I alter this, can you see this red is here? There is look at this red. Can you see? There's a mixture somewhere. So now, this is where the problem is coming from. The problem is not even the space now, per se. The problem is from this side, from here. So I need to pass different dimension accurately. And yes, basically. So now the assignment I'm giving you guys is this. Go and make research. How can we create 4 plots? If this can accept up to how many? 1, 2, 3, 4. That means this also should be able to accept. Space could be a factor anyways, and this also can also be a factor, right? So go and check how to create 4 plots using subplots. Yes, using sub. That's the assignment. That's the assignment. All right, so let's just proceed with what we have started. All right, so that's that. So now we have other examples here. You can explore them. Now let us talk about map before we close. So quickly, I'm going to be talking about map. Map, yes, map. We're going to be talking about map before we close. So I'm going to create a kind of sample data set, and there are different, then let's see if we can create map. Map, let's see if we can create map. Yes. So we should be able to create map now. So this meeting will end shortly. So once it ends, just you can rejoin. So I'm going to stop at map. So I'll just create map, then I will end the class for today. So I'm going to be creating United States, India, Brazil, Nigeria, and Germany. All right. So this meeting will end shortly. Kindly rejoin with the same link and we progress in the class.